Hey guys, welcome back to AlgoYogi, and we are doing tree series. Our next problem in the list is delete leaves with a given value, and that's a binary tree that we're given here. So given a binary tree root and an integer target, delete all the leaf nodes with value target. Note that once you delete a leaf node with value target, if its parent node becomes a leaf node and that also has the target value, then we also have to delete that value. So now let's see first example. So if you see here, let me zoom in. So if you see over here, when we are traversing this array, we come over to 2 and then we see a leaf node and our target given is 2. That's over here. Target is 2. Now this is what we need to delete. Now we have to get rid of 2. However, if you see that they have shown in the second diagram that now when after deleting this target or this leaf node which was equal to target and we had to delete it, then we had to get rid of this as well, and then we get our final answer and we return root, right? And so tell me, how are we going to do it? How we must have done it? So we see a traversal and we see that whenever we come across a leaf node and we see that has the target value, then we basically return none from that place. So if we return none from here and then we go up here, this returns none and this is done. So now it doesn't exist anymore, just like here. But however, how are we going to make sure that if when we are returning back to the parent, then if parent also has the target value, then we also need to return none from that node as well, if it is a leaf node. So in that case, I would say what we're going to actually do is we will use DFS, and in DFS we will use postorder traversal. All right, why? So that whenever I am processing a root that could be any of these values. So post order is about processing left, right, and root. So even if it is a leaf node, then we are basically processing the none left node, none right node. Then if my leaf node is equal to the target, then I am basically not returning anything. I'm returning none back to the parent. However, at parent, I will still be going to the right side and try to check if do I have a leaf node or something, and do I need to delete that, and if I had to, that will return basically none from that. And now it is also a leaf, right? If it is also a leaf, now if this also equals to the target, then we also return none from here. Otherwise, if this is not the leaf node, then we return whatever we received from the other side. So then we just return this particular non-leaf node just itself. So that's how we're going to do it. So we will use post order, and we will keep traversing from leaf node until from root node until we get to the leaf node, and we make a check if it is equal to target. Then if yes, then delete it, and then basically process the parent and keep returning whatever values basically will be the valid values after deleting the the leaf nodes which are equal to target. All right, let's code up our solution. It's going to be pretty simple. We're going to have our post order DFS. So if root is none, if my root is none, then I return none because I want to return nodes here. All right, But since it's a post-order traversal, I want to process my left side, right side, and then the root. And I'm going to basically not return anything, but since I have a root which is not none, then I want to assign left here to my self dot, sorry about that, I think that is not good, self dot remove leaf nodes and left side target. And let's do the same thing for right side. So this will be basically returning us whatever remain in left side after we're done processing everything. But at the end of the day, we will have certain base cases, which is if it is a leaf node, we will check that right below it, where we will be processing the root. So root.write would be running this same function on this. Now what happens is if my root.left is none and my root.right is none and it is equal to target, then my root.value is equals to target, then I return none. If only it is a leaf node and its value is equal to target. So if it could be in the middle of the node and then it might not have left child but it has right child, then we're not gonna do anything to the root because it's being returned some value from right side. So then this is not a leaf node anymore. But in case the left side, because that will be processed before we come down to the root, then we have to also take care of this value as well and return none from here if that value also becomes a leaf node, and then we had to delete that. That's when we will process that particular leaf node. It was not a leaf node, but then because of these values being returned from here, and that becomes a leaf node. So anyway, I think that is all. That's all recursive solution should be doing right now. So let me zoom out and run this solution for you guys, and I really hope it is a success. It is. Okay, let's run it on over all the examples. 100%, that's so efficient. All right, let's write down the time complexity. Time complexity worst case would be big of n because we're processing all the nodes, and then space complexity will also be big of n. We can write it big of h since we are basically going up. Our stack is only having like h amount of nodes in the stack. In worst case n, and h could be equal to n, so h can be equal to n in worst case. Alright, let's go back to AlgoYogi and mark this problem solved. We are quite close to solving all the problems. 4 more problems to go. Let's get it.